Hello guys, my name is Balkrishna Srivastava and welcome to Code with BK. So in this video, we write a Java code to convert a decimal value to its corresponding hexadecimal value. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 2 to 3 are subscribed. More than 95% of my audience is not subscribed and your subscription is very important. So please do subscribe to my channel. And one more thing before we start is that I teach coding in Hindi as well on a separate Code with BK Hindi channel. So this English channel was the first that I started back in 2018, and then I started getting requests if I could teach in Hindi as well. So I started this separate Hindi channel. So if you guys are comfortable with Hindi, it is a request. If you guys could spare 5 minutes, check out this channel. Let me know your thoughts, reviews about this channel in the comments, please. Okay. All right. So we need to convert a decimal value to its corresponding hexadecimal value. And I am going to explain about the number systems first, what is decimal number system, hexadecimal system, and then I move on to the process of conversion and then coding it. So if you guys are aware about what these number systems are, you can directly skip on to the part where I do the conversion. Okay. So we have a decimal number system. First things first, what is a number system and why do we need this? Okay. So suppose if I have say 20 balls, they look like balls 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I ask you how many balls are these? You say 20 right away. Okay. So this is a number in the decimal number system, and this decimal number system is what we use in our day-to-day lives. Okay. So number system is a method to represent a quantity as a number. Okay. So there are two things here, quantity and the number. Quantity is 20 and the number here is 20. Okay. And this is the number system that we use in our day-to-day lives because the word deci means 10, and we use the 10 symbols 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. We use 10 symbols to represent any quantity as a number, and this is what we use in our day-to-day lives. Okay, so number system is a way to represent a quantity as a number. Decimal number system has 10 symbols 0 to 9. Similarly, we have hexadecimal number system that again will represent a quantity as a number. Okay, using the symbols it has. So hexadeci means 16. Hexa plus deci, 6 plus 10, 16. So it has 16 symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it has A, B, C, D, E, F, lowercase or uppercase, where A represents 10, B is 11, C is 12, D is 13, E is 14, F is 15. Okay. The tricky part here is now try to understand the fact that decimal number system can represent 10 quantities by using one symbol. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 quantity, 1 quantity, 2 quantity, 3 quantity. Okay. Hexadecimal number system can represent 16 quantities uniquely with different symbols. So after 9, in order to represent 10 quantities, it uses symbol A, which is equivalent to our decimal value 10. Okay, you're getting my point? This is just to demonstrate the equivalent values they hold. A means 10, B means 11 quantity, C means 12 quantity, D is 13, E is 14, F is 50. Okay, so apart from the first 10, they have A, B, C, D, E, F. If you want to compare this, octal is 0 to 7. Okay, 8 symbols. So 0, 1, 2, 3, 4, 5, 6, 7. It does not have 8 and 9, just like this decimal number system has. Similarly, hexadecimal number system has A to F, which decimal does not. Okay, so octal can only represent 8 quantities uniquely using one single symbol 0 to 7. Okay, decimal can do with 10 symbols, hexadecimal can use with 16 symbols, and then we move on to combinations of singles. That is, after 9 we have 10. Okay, so after F also we have 10. After 7 also we have 10. Okay, so if you check out my video where I tell you about decimal to octal conversion, there I've shown you the counting is like 0, 1, 2, 3, 4, 5, 7, then not 8, it comes 10, 11, 12, 13, 14, 15, 16, 17, and not 18 because it does not have 8. After 7 it is 20, 10, 21, 22, 23, 24, 25, 26, 27, and then 30. Okay, just as after 9 we have 10, after 19 we have 20, after 29 we have 30. Okay, alright, I guess I'm going way too deep into this. Alright, number system representing quantity as a number. Okay, quantity remains the same across two number systems, number may differ. Okay, so this has base 10 because it uses 10 symbols. This has base 16, it uses 16 symbols. So representing number 20 in decimal number system is 20 with a base 10. So this number 20 is from decimal number system equal to, so this represents a quantity which is equal to some number in hexadecimal number system because quantity remains the same. Okay, now we come to our part of decimal to hexadecimal conversion. Okay, given a decimal value, how do I find the corresponding hexadecimal number? Okay, so there is a standard division method. This is my number that I need to convert to hexadecimal number. I say divided by 16 because we are converting decimal to hexadecimal, that has base 16. Divide by 16 as long as this does not go 0, and append remainders. What do I mean by this is 16 1 is 16, remainder is 4. 16 zeros are 0, remainder is 1. Okay, we reach 0, we stop the division. Okay, we append remainders from bottom to top. So 1 4 1 and 4 in base 16 is 20 in base 10. So this is going to be 1 4 in base 16. Let us do another one very quickly. I have 100. I need to divide it by 16 as long as it does not go 0. 16 6 is 96, remainder is 4. 16 zeros are 0, remainder is 6. We reach 0, we stop. We append these remainders. 6 and 4 in base 16 is equal to 100 in base 10. We do it again for 1000. Okay, divide by 16. 16 6 is 96, 40, 16 2 ja 32, remainder is 8. Okay, 16 3s are 48, remainder is 14, which is basically E. Okay, then again 16 zeros are 0, remainder is 3. Okay, because 14 is E. Okay, so there is a separate symbol to represent the quantity 14, just as we have 10 11 12 13 and 15 in hexadecimal number system. Okay, we append these 3. So we append 3 and then the symbol E and then 8, which is in base 16 equal to 1000. Okay, in base 10. Right, it might be possible that you find it tough to understand why are we appending E. Okay, so think in terms of numbers with symbols, and symbols can be anything. Okay, if you think them as simply symbols and not numbers, you will be okay. We have 10 symbols, we use that to represent a quantity as a number. Okay, in this case we have 16 symbols. So just as we can do 308 318 328, we can also do 3E8 because E is representing a quantity. Okay, all right. If you want to do the reverse, that is hexadecimal to decimal, so you do is the process is standard that you place digits separately. For this you do 64, for this you do 3E8. Okay, since you're converting from 16 base, so you need to multiply all of them by 16. Okay, so basically the digits multiplied by 16. Okay, into 16. Okay, now in each set of digits from right to left, give 16 power of 0, incrementing it by 1. So 0 1, give 16 power of 0, incrementing it by 1, give 16 power of 0, incrementing it by 1. So this is 2, and add all of them. Okay, so this will give us the corresponding decimal value. So this is 16 plus 4 into 16 to the power 0 is 1, is 4 is 20, 14 to the 16 is 22 base 10. This is 16 6 and 96 plus 4 into 16 to the power 0 is 1 plus 4 is 100. So 100 to the base 10 is 16 to the power 64 to the power to the base 16. Then we have 3E8. So 16 square 256 into 3. Right. And this is E is 14 into 16. Okay. Plus 8. So 256 into 3 is going to be 18. 1 carry 5 15 16 1 carry 7. 14 into 16 is going to be 6 24 to carry 84. And 14. Okay. 4 8 to 12 1 carry 2 to 4. So 7 6 8 plus 2 2 4 plus 8 8 for flows 12 8 20. 6 plus 2 8 plus 2 10 1 carry 7 plus 9 10. This is 1000. This is 1000 to the base 10. Okay, all right, so we know how the conversion is. We just need to replicate this in our code. Okay, so we use int to store the decimal value because the day-to-day numbers that we use, you can store it in integer types because it uses 0 to 9 digits. Okay, we use string to store hexadecimal values because it has symbols A to F. Okay, we cannot have symbols A to F in our int type. Okay, so we will write a function that takes the integer, which is the decimal value, okay, returns a string which is going to be the corresponding hexadecimal value, and we do the same process. Okay, we handle the case of 0 separately because 0 in base 10 is 0 in base 16. Let me do this first. If d equal to 0, return 0 as a string. Okay, then we do this division thing. We divide d by 16 as long as d does not go to 0. So our stopping condition is d not equal to 0. When we are dividing, we need to save the remainder. So we find the remainder first when d is being divided by 16. It shows thumbs up. And then we divide it by 16. Okay, integer division by 16 because all of these are integer divisions. Okay, What I mean to say is I have a string hexadecimal to append the remainders, okay, and this is the string that I return. Okay, I say while d not equal to 0, I'll find the remainder as int r is d percent 16. Okay, this gives us the remainder when d is divided by 16. So when 20 is divided by 16, remainder is 4. That's what we want to store. We append remainder to this string. Okay, sorry, we add it, appending is to the right end, we add it to the left end plus decimal. Okay, and then we do d equal to d by 16. Okay, so this one single iteration is basically this single step where we are finding the remainder, then we are finding the quotient when d is divided by 16 and storing it back into d. Alright, finally returning the hexadecimal value. Let me just test this. I'm gonna try run and show you this in a moment. So int d is say 100, okay, is out, plus in hexadecimal is plus decimal to hexadecimal, decimal to hexadecimal d. This should come out to be 64. Okay, then let's do with 1000. Okay, 1000 should come out to be 3e8. Okay, but we are getting 3148 because we are appending 14 as it is. We need to convert 14 to e, and similarly if the remainders are 10 to 15, we need to convert them into a to f respectively. So if my remainder is less than 10, okay, I append it as it is to hexadecimal. Okay, else what I do, I say t is r minus 10. Sorry, t is r minus 10. I say to hexadecimal I need to add a to f for 10 to 15. So I say a plus t and the corresponding char after a plus t to hexadecimal. So what I'm doing here is, suppose r is 10, remainder is 10, so I will need a. R is 10, t is r minus 10 will give me 0. So character at a plus 0 is going to give me a, so I append a. Similarly, when r is 14, r minus 10 is going to be 4. So this is going to give me corresponding character after a plus 4, which is e, which I'm going to append to hexadecimal. Now when I run this is going to be fine. 38. Okay. So let me just dry run this quickly. So the values that I have is this hexadecimal string, which is blank. I have the value d. Okay, d is how much? So let's do it for 1000. Okay, so d is 1000, and I have condition d not equal to 0. Okay, I have r as d percent 16. Okay, this is r. Okay, we have r is less than 0 condition, less than 10 condition. We have d by 16 goes back into d. Okay, so we are here when hexadecimal is a blank and d is 1000. D is not equal to 0 is true. Okay, because d is 1000. D percent 16 is remainder when 1000 divided by 16. 1000 divided by 16 will give you remainder. It was the remainder here was 8. Okay, this is 8. Okay, all right. You say r is less than 10. R is less than 10 is true. So you do this. R plus hexadecimal. So you do r plus hexadecimal is going to be 8 plus blank. In Java, you can append, add an integer, concatenate an integer to a string. So this becomes 8. Okay, which we are storing back into hexadecimal. So r plus hexadecimal is this, which we are storing back into hexadecimal. So this is 8 now. Okay, if part is done, we come here, d is d by 16. D by 16 is 1000 by 16 will give us the quotient. 16 6 is 96, 40, 16 2 is 32. Okay, 62 was the quotient, right? Nice. 62, which goes back into d. D by 16 goes back into d, so this is now 62. So one iteration is done and we have one remainder in my string. Okay, then we do d not equal to 0. D not equal to 0 is true because d is 62, so this is true. You come here, r is d percent 16. Remainder when 62 is divided by 16 is 14. Okay, okay, 62% 16 is will give you 14. R is less than 10 is false. Okay, so we do this part. We calculate t is r minus 10. T is going to be 14 minus 10 equal to 4. Okay, a plus t is going to give us a plus t is equal to a plus 4. B, C, D, E. Okay, so E plus hexadecimal back into hexadecimal. So E character E plus hexadecimal, which is 8, back into hexadecimal, which is E8 string. So hexadecimal is E8. Okay, and then you do D equal to D by 16, 62 by 16, 16, 3 is a 48, this is 3. Okay, D by 16 is 3, goes back into D. All right, then we go back to check for while loop condition. D not equal to 0 is still true because D is 3. R is D percent 16, R is D is 3% 16 is 3, R is less than 10 is true. Okay, so we do hexadecimal is R plus hexadecimal. R plus hexadecimal is going to be R is 3 plus hexadecimal is E8. Okay, so appending an integer to this string, we get 3E8, and this goes back into hexadecimal. Okay, so this is 3E8 now, hexadecimal. Okay, then we would equal D by 16, 3 by 16 integer driven will give us 0. Okay, goes back into D. All right, you say D not equal to 0 is now false. You come out of the while loop, you return hexadecimal, which is this value right now. So you get 3E8. Okay, all right. Okay, so let me just run this for say for int I equal to 0, I less than equal to 20. I'll say I in hexadecimal is this. Okay, so 0 to 9 is the same. For 10 we have a separate symbol, so we go till F. After F, hexadecimal runs out of symbols. Okay, so now it has to use combinations just as the decimal number system does. After 9 it is running out of symbols, so it starts 1 0. Same is the thing where hexadecimal starts with 1 0. After 1 it appends 0, then it appends 1, then all the combination till 9. So combining 1 with other symbols is done, so it starts with 2 0. Similarly, when combining 1 with other symbols is done in hexadecimal, it will start with 2. So when I go till 30, you see 1 is appended with all the symbols now, 0 to 9 and A to F. Let me make this 40. Okay, 1 to 9, A to 1 to 9 till here, 0 to 9. Okay, and A to F. So running out of symbols to append after 1, so it starts with 2 0, and 2 8 2 9 till 2F. So I'll make it 60, make you show you 2F. Okay, so 2 0 to 2F and then 3 0. Okay, so the counting is the same. They use their unique symbols. Okay, so decimal has 9 unique symbols, hexadecimal has 16. After the unique symbols are over, after 9 it uses 1 0 1 1 1 2. Similarly, it uses 1 0 1 2. It goes till 1 9 because after 9 it does not have any symbol. It goes till 1 F because after 1 9 it has 1 A B C D E F left as well. Okay, counting remains the same. Okay, very interesting this is. Okay, so one last thing is, when you do decimal to binary, which is base 2, or decimal to octal, the process remains the same. That is, you have to keep dividing it by the base. So in case of decimal to hexadecimal, you are dividing by 16. In decimal to octal, you keep dividing it by 8. In decimal to binary, you keep dividing it by 2. Okay, I've already uploaded separate videos for it. So you do this, you have balloons. Okay, all right, and then you have to append remainders. Okay, so when you do decimal to binary or decimal to octal, only the base to which you are converting to, okay, is changing because you have to divide it by that corresponding base. Otherwise, the entire process where you find the quotient, find the remainder, append the remainder is the same. All right, okay, so this was your Java code for decimal to hexadecimal conversion. Okay, so I hope this video was helpful and you like this video. So if there is any doubt, there's a part you do not understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.